So here's my recap on simultaneous equations. Let's start with our procedure. We follow the same method every time. Step 1 is to make sure we have the same number of x's or y's. Step 2, we check the signs and either add or subtract, remembering that if the signs are the same we subtract, and if the signs are different that we add. Once we've created a new equation, we'll have one unknown, so we solve it, and then we substitute that answer into any of the equations to find the other unknown. Okay, let's just have a quick reminder of how this works in practice. So here I have my first example. Here I can see clearly that I've got the same number of x's in both equations, and the x's have the same signs. They are both positive x's. So what do I do? When the signs are the same, I need to subtract. So I'm going to go through, I'm going to do x take away x, which leaves me with nada. 6y take away 2y leaves me with 4y. 17 take away 9 leaves me with 8. Now I've got an equation with only one unknown in it, y. How do I get the y by itself? Well, I divide both sides by 4 and find out that y is equal to 2. Now to find my other unknown, I can choose any of my equations. I'm going to choose this second one here, only because it's slightly easier. There are fewer y's in this question than there are in this one. First of all, I'm going to write it out again. X plus 2y is equal to 9. Now I've just found out that y is equal to 2. So I can rewrite this as x plus 2 times 2 makes 4 is equal to 9. If I subtract 4 from both sides, I find out that x must be equal to 5. And there's my final answer. X equals 5, y equals 2. In our second example, we see things aren't quite as straightforward. I don't have the same number of x's, and I don't have the same number of y's. So to start with, I need to make sure I've either got the same number of x's or the same number of y's. And the easiest thing to do in this case is to take all of my first equation and multiply it by 2. What happens when I do that? I end up with 4x plus 2y equals 22. Now I've used that equation, so I can put a line through it. And I can see that between these two equations, I now have the same number of y's in each equation. In fact, it was because I had a 2 in front of the y that I wanted to multiply my first equation by 2, because that let me get the same number of y's in both equations. Now I can solve this as I would have done the previous problem. I've got the same number of y's. This time the signs are different. This is a negative 2y and this is a positive 2y. If the signs are different, I need to add my two equations. 3x plus 4x makes 7x. Minus 2y plus 2y makes nada. 6 plus 22 is 28. Now I can solve this equation, divide by 7, and find out that x must be equal to 4. Now I know that x is equal to 4, I can choose any of my equations. I'm going to pick this one here. So that's 3x minus 2y is equal to 6. I know that x is 4. So 3x is 3 times 4, which is 12. 12 take away 2y is equal to 6. Well, solving this equation to get the y by itself, if I take 12 away from both sides, I find out that minus 2y is equal to minus 6. Divide by minus 2 and find out that y must be equal to 3. Does that make sense? Well, yes it does, because if I put that back into here, 2 times by 3 makes 6, and 12 take away 6 makes 6. Now in my third example, things are a little bit more complicated. I haven't got the same number of x's, and I haven't got the same number of y's. But I also can't multiply 2 to make 5, or 3 to make 4, or multiply 5 to make 2, or 4 to make 3. So these are the most complicated type of equation. And what I have to do here is a little bit similar to what I did in example 2. Only instead of multiplying just one equation, I need to multiply both equations. Now in this question, I'm going to choose to make the y's the same. It doesn't matter whether we pick the x's or the y's, but my personal choice in this question is to pick the y's. Now if I want to make the same number of y's in both equations, I'm going to need to multiply all of this equation by 4. And that's because I've got 4 y's in my second equation. And if I do that, I end up with 4 times 2, which is 8x, 4 times 3, which is 12y, and 4 times 9, which is 36. Now changing colour, I need to multiply all of the second equation by 3. And if I do that, 3 times by 5 gives me 15x. 3 times by 4 gives me 12y. Look at this, brilliant news that I've got the same number of y's in both equations. Is equal to 19 times by 3, which is 57. Now I've got the same number of y's in both equations, I can solve this just as I would have done any previous problem. I've got the same number of y's and the signs are the same. So what am I going to do? I'm going to subtract. 8 take away 15 makes minus 7x. 12y take away 12y, nada. 36 take away 57 is minus 21. Divide both sides through by minus 7, and I find out that x is equal to 3. Now I know that x is equal to 3, I can choose any of my equations, and in fact I can really choose any of my equations. I can still use these ones up here. So I'm going to pick the first one, 2x plus 3y equals 9. I know that x must be equal to 3, so 2 times 3 would give me 6 plus 3y equals 9. Take 6 away from both sides to find out that 3y must be equal to 3. So y must be 1. Now this was a little bit tricky and we had a lot of negative numbers involved here, and to make this a little bit easier I could have done this a little bit differently. If instead of taking 15 away from 8 I was to write these equations down the other way round, 15x plus 12y equals 57 and 8x plus 12y equals 36. If I do my subtraction this way round, I don't get any negative numbers. 15 take away 8 leaves me 7x, nada, and 21. And notice that I end up with the same solution, dividing by 7, that x is equal to 3. So that might have just made that last bit a little bit simpler. Okay, so remembering back to the top, our 4 steps: make sure that we have the same number of x's or y's, check the signs, if they're the same, subtract, if they're different, then add. We'll make a new equation that only has one unknown, and we're going to solve it, and then we're going to substitute our answer into one of the equations to find the other unknown. Please make sure you stop and go back through this video. You remember you can pause, rewind, and go through at your own rate. Good luck!